Presented by Caltech.
He got his undergraduate degree at Auburn, his PhD at Texas.
A&M.
Texas A&M, sorry. Ooh, that's my fault. Jimmy has a long career working on commons problems, collective action, agency problems. He's an experimental economist who's done a lot of work. One of his co-conspirators was Lynn Ostrom, who got a Nobel Prize for this kind of work. Jimmy's going to introduce us to some of the economics of the problem.
Thanks, John. Yeah, let me start by saying thank you for the opportunity to be here. As I thought about this talk, and it's sort of been changing almost every minute, but I thought I'd start actually with just a bit of a discussion about Lynn Ostrom, who I'm not sure if all of you know about Lynn and her early work, but in many ways, in addition to a few people in this audience, Lynn was one of the major reasons I got into thinking about the issues of the commons and actually trying to understand collective action and decision making in the settings of a common pool resource. So this talk is not going to be so much about California water. You're not going to see maps. You're not going to see specifics. It's really about, John said, about maybe just presenting some of the basic economic tools, models. How do we go about thinking about some of these issues when they relate to the commons? But before I begin, I'm going to come back to this at the end as well. But I'm going to try to sell a book. Maybe I'll try to sell two at the end. But if you have not read or seen Lynn's book, Governing the Commons, it's well worth reading. And I think most of you would really enjoy reading chapter 4. So Lynn, when she was working on her PhD in political science at UCLA, her dissertation was examining collective action related to water resource issues in Southern California. And chapter 4 deals primarily with the process, the collective action that occurred in the Raymond Basin, which was sort of the starting point, and the success of that. And then she moves on to the West Basin and talks about why did that not work so well. So Lynn was at the very heart of sort of thinking about these issues and how do you get these appropriators with very differing rights and the potential for differing rights, the competing for rights, how do you get them to sit down and talk about and solve some of these problems? So it's a really important and interesting work, and which this then becomes sort of the foundation for Lynn receiving the Nobel Prize in Economics in 2009. So I'm going to talk about common pool resources, but I'm going to step back a little bit. So where does this sort of fit into economics? And then as I move along, I'll talk about some of the experiments we've done, and I'll talk a little bit about what does it mean to run an economics experiment, even though since so many people do it at Caltech, maybe you know a lot more about it than I do. I don't know. Okay. So as I think we're back down to So as I think about economics, I start off with this idea that the most fundamental concept in economics is this idea of opportunity cost. It doesn't matter what you're talking about. Resources are scarce, and if you're going to use them here, you're going to give up something. So it always comes back to back to opportunity cost, and that leads in economics to thinking about appropriation rules and allocation mechanisms, and the focus on how do we get these resources allocated to their highest valued uses. So the next step for me then is when we move toward the commons, we're going to end up talking about a lack of effective property rights. Why does the lack of effective property rights lead to overuse and resource degradation? And sort of the final, I think, overlying area is a question of, as we think about policy changes, one thing that becomes very clear in economics is we're not as smart as we'd like to be. And almost all policies end up creating unintended consequences. And I think it's incredibly important as we think about policy, is to think about how these smart people out there are going to take advantage of the things that we don't want them to take advantage of. Okay, so that's kind of the overview of where this is going. So back, I don't know, somewhere in the 1950s, 60s, somewhere in there, economists started to think about this question of what's called the nature of goods, which I think is really the nature of goods and the nature of allocation mechanisms. But let's see if I can do this. So this is a very simple idea, but it's a useful idea for starting to think about the problem of allocation of goods. So think about this as a scale that goes from very high to very low in terms of what's sometimes called rivalry and sometimes called subtractability and use. So most of the goods we think about, the ones we used to buy in a market, I guess we buy now in an electronic market off of Amazon now, but they fall into this category of highly rival. If I purchase the good, it's there for me, I use it, and this includes water. If it's in a bottle, I drink that water, you don't want that bottle. Okay, you don't want that water. So private goods, the ones that we usually think about markets, fit into this category of high rivalry, and on this axis, we think about the ability to exclude. In this case, it's ability to exclude those you don't want to be using this. So in markets, we have laws. We have laws against stealing. We have other mechanisms to keep those from taking the goods who do not pay for those goods. So this fits into the category of private goods. We can think about goods in which we can use markets to allocate those goods. And actually, they have low rivalry. Those are called toll goods. Much of my early, still going, in terms of experiments was to look at situations in which we have low rivalry in use, low subtractability, and we also have low ability to exclude. And this, in economics, is this idea of public goods. Not goods provided by public agencies, just public goods. That's the term. So, and the key thing here is if these are provided, and because of the non-rivalry, then they're there to benefit everyone. So, common pool resources, which is basically the problem of the commons, it's the problem of underground water. So what do we have here? We have high rivalry. If somebody pumps that water out, that water's not there for somebody else. And we have low excludability because of lack of property rights. Okay? And in some case, there may be property rights, but those property rights are over a large group of users, so they're not very well-defined property rights. So this is where we're going to head in terms of thinking about, that's what you have been thinking about in terms of many of the water issues. So, all right. So John suggested just talking about some basic ideas in economics and basic models. So I'm going to start off with what I think of is sort of the first basic model to think about common pool resources. It's the model that we brought to the lab. It's a model that was first, at least to my knowledge, discussed in 1954 in an article in the Journal of Political Economy by a guy named Scott Gordon. So I often think of this as the Gordon model. So basically we have a resource, and we have open access. It's there for everybody to appropriate from, okay? And we're going to start off with a simple world in which we imagine that there's full replenishment in every period, okay? So in the simplest case, we can think about the resource generates valued resource units. You can think of it as water that's being pumped, where the level of water extracted is a quadratic function of extraction effort. So we're literally just in this simple world thinking about we're going to use resources to extract the water that has value, okay? And in the world of economics, we're going to have declining marginal product of those inputs. But going back to opportunity costs, this labor has an opportunity cost. So in this simple world, that labor could be used somewhere else. So we're going to assume it has a value W, okay? It's this foregone earnings for which that labor could be used. So you can think about this as, in Scott Gordon's case, he was originally thinking about fishing, and labor was fishermen going out and competing with each other for the fish. But you can think about this as pumping and as being some sort of resource cost, labor cost to pump the water. So in this world, so in summary, we have a quadratic production function for labor that yields a resource that has value. So we'll put some dollar signs in here. So it's of this form, okay? So it's quadratic, which gives us an average product of labor, which is a linear downward sloping average product of labor function, and we have a marginal product of labor that is also downward sloping. So this leads us to sort of a classic story in economics about using resources. So this is taught in certainly every intermediate economics class. Okay, so we're going to use labor to appropriate to produce this good water, which has some value. Okay, right now we're assuming the water has the same value for everyone. We have a declining value average product curve, and we have a declining value marginal cost curve. Okay, so the easiest way to think about this is these are individual workers, and they come out and they're there, they extract, somebody else comes along, or they come out simultaneously. So as we move along here, with more and more labor being used, the value of the marginal product of that labor is going down, and the value of its average product is going down. Okay? So if we start moving out, and if we were going to limit the amount of labor that's used, and we were going to limit it to optimize, to find the efficient amount of labor to use, we would stop right here. So we would stop where the marginal cost of the labor equals the value of the marginal product of labor. Okay? So if we had collective action, if somebody was organizing that labor, we would use this much labor, we'd use this much labor to pump water, and that would lead in economics to something called rents. So in economics, rents are these returns to these valuable assets. Okay? So here we are. So we have collective action, everything's working fine. All right? We're optimizing, we're getting as much value out of the resource as possible. This area is a dollar amount that equals those rents. But something starts to unfold. We think, well, there's these other workers out there, and they're not part of this agreement. So what do? Well, in this story, then the worker says, okay, if I go out and I work outside of this resource, I can earn W. Okay? And if I go and work in this resource, what can I earn? Well, the value of my average product will be up here. So I'll earn much more by adding my labor to this resource than I would if I go and earn W. I earn this much. This is my wage rate. So this guy says, no, I'm going to come in and I'm going to appropriate from this resource. And the next guy does, and the next guy does, and the next guy does. Okay, and as they do that, the value of the average product goes down. Okay, and it continues to go down, and where does it stop? Well, at this point, the value to the worker, to the laborer, the value of their labor going in is exactly equal to their wage. So do other workers continue to go in? Well, they have no incentive to. So what they do is this is this idea that labor you would stop at this point, and because its opportunity cost is higher than what they would earn from the resource. Okay, so this is what's called the open access equilibrium. But notice at this point, all the rents have been utilized; they've been dissipated. So we're at a point of zero rents. The average return from investing in the resource is the same as the opportunity cost of wage. So there's nothing in terms of excess being earned from the resource. So this is the idea. Okay? So, but the story really may be worse than that. So that's a story about utilizing the resource inefficiently. But in the real world, many other things happen. So in the real world, and some of the things that have been coming up, we have this was a world that I was talking about in which we had replenishment rates each period that were complete. In a sense, the resource, even though it was being utilized, this resource was being replenished every period. So it's going back to its natural state. Okay? But that's not always the case, and we know that. So in the real world, we have high variability in the replenishment rates. We also have another problem, which is called, often in the case of water, it's called the race to the water. So it's this idea that we have a time dependence. And in fact, in Lynn's book, she talks about how the rights to pump water are uncertain, and there are different types of rights. And so in some cases, individuals or groups are pumping, at a faster rate than they normally would, so that if there is an action taken down the road, their property rights will be even greater than they were. So they're planning on the idea that their rights to the water is going to be dependent on their past use. So they have an extra incentive. This is in a sense, this is an unintended consequence of the type of property rights that are being given to the users. So beyond that, though, the story continues to get worse. So the resource itself can be degraded, and this resource is sitting in this water resource is sitting in a broader resource system. So if we think about the degradation of the resource, that leads to degradation of the broader system. So that kind of leads us to, well, maybe what we could do is limit the access, just restrict the access. And even there we have problems that are related to non-cooperation and strategic behavior. So this is when we kind of move to the lab. So we take this model and we bring subjects to our lab. And these subjects are going to make, you can think of them as appropriation decisions. We call them investment decisions. They make an investment, which is an appropriation. They get something in return. Okay? These are student subjects who come into the lab. They're paid for being there, and what they get paid depends on what they do and what everybody else does. Okay? So in the first experiments we did, we would have groups of 8 come in. They make anonymous decisions, and the setting is this Scott-Gordon model. The setting is designed to capture the incentives of a common pool resource. In the case of the experiments, we repeat each time. We repeat over and over the decisions. Okay? They're given information on if the level of appropriation is at this level, here's the marginal return, here's the average return, here's the total return, et cetera. But again, they're anonymous. They're in groups of 8. They're not sitting there, at least initially, they're sitting there making decisions independently. Okay? So in this case, if we go back and we think about game theory and non-cooperative behavior, then in fact we will get something that's in between the case of full rent dissipation and maximal rents. Okay? In our particular design, they'll earn 37% of the maximum rents that they would if they optimize. Okay? So the results I'm going to show you are based on thinking in terms of, okay, in their decision-making process, what part of the rents do they earn? Okay? In the first experiments that I'm going to talk about, we're going to vary appropriation capacity. How much can they invest? We're going to vary something. We're going to move toward face-to-face communication where they can talk about the problem. No binding contracts, but they can talk about the problem. And then we're going to talk about when they can sanction each other. So in the sanction experiments, they have the opportunity to spend money, to take money away from somebody else. Okay? So sanctions aren't costless, but and in fact, they're costly to both the person imposing the sanction and to the person getting sanctioned. Okay, so what do we get? This is sort of an overview. So, okay. So the non-cooperative equilibrium in this game is that each subject would invest 8 tokens in this CPR, in this commons. Okay? And again, if they do that, they'll earn 37% of the maximum rents they could earn. All right? In the low capacity setting, basically, they're limited to 10 tokens. They can put those tokens in an outside option, or they can use them to invest in this resource, in use of this resource, if you want to think of it that way. Okay? So their capacity is pretty close to the Nash equilibrium. All right? And in fact, what we see is that in the first 10 decision rounds on average, this has across a lot of different groups, they earn 47%, which declines to 35% in later rounds. Okay? So actually, in that sense, we're getting an outcome that's pretty close to what non-cooperative game theory would predict, okay, on average. And actually, the game here predicts that they'll all be investing 8. And we're not getting that. In fact, what we found was we've got a really combination. So this is, you've got these people who, at this point, aren't communicating. Some are investing everything they can, and some are holding back, trying to earn something from this resource. So we moved from that to what I'm going to call the high capacity. So we moved them to having 25 tokens. So they can invest up to 25 tokens. Nothing else has changed in the game. So the non-cooperative game equilibrium is still to everybody investing 8 tokens in this commons. Okay, so what do we get? Well, so we get this funny figure of over the first 10 rounds, rents are negative 22% of optimum. So how do we get that? How do we get a negative return? Well, if you go back and think about this graph that I had up earlier, they're actually investing past the point where the average return is below the wage rate. Okay? Now again, they're not coordinating, so this isn't just they're doing something stupid, but in the end, because they're not coordinating and they're not acting cooperatively, they're actually getting a return that's lower than they would if they had just put their tokens into this sure thing, this outside opportunity. They learn a little bit over time, and they come up to 21% in the latter rounds of the experiment. So after we've done this, we move toward this idea of, okay, so what if we give them these opportunities to collectively think about the problem? In the first case, we give them after the first 10 rounds, again, where they're earning negative rents, they have one opportunity. They sit down face to face and they talk about the problem. Okay? They often talk about what would be the best thing to do, and in many cases, they talk about an agreement. You do this, you do this, you do this, and they agree to that. And in fact, this is a pretty big increase. They go from negative earnings in terms of the resource up to 53%. We go to still well below optimum though. In the next step, we go to repeated communication. So now they're beginning to come to sit down and talk about the problem after every period. Okay. And we actually go from, in this case, they were averaging 9% in the first 10 rounds, 73%, and once they have this opportunity for repeated communication. So what about sanctioning? Well, sanctioning works 37%. This is no sanctioning. When they go to this opportunity to sanction each other, things go up, but they're not great. Okay? And in fact, what we start to see is they sanction those that are the high appropriators, but the high appropriators are those that get sanctioned actually turn around and start sanctioning those that are cooperating. So we get sort of this blind revenge because they don't know who's sanctioning. They don't know who's imposing these sanctions on each other. So we see this blind revenge. And when we go to one-shot communication, they can talk about the problem, and then they have the sanctioning opportunity. We go back to some fairly successful groups in terms of earning rents from the resource. After this, these are all cases where the opportunity to sanction has been imposed. It's from the outside. We let them sit down and talk about the problem and talk about whether they want to have something like a sanctioning institution. And I mean, this is kind of interesting. So if we have one-shot communication and they choose sanctioning, these groups went from negative 11% rents to 91%. In the case where they said, nope, we don't need it, we're going to talk about the problem, we won't need it, this was actually a group that was groups that were fairly cooperative to begin with, and this goes up to 53%. And this is going up to 53% because actually they start off, they earn relatively high rents, and then they decline over time after they can't sanction each other. Mm-hmm.
Just for clarification, the institutional change is anticipated in round one. You tell them at
Nope.
the experiment?
No.
So I should treat all the rows on the left-hand side as being in the same experimental context?
Yes, except as we move through this, and it's especially down in here, we're actually taking subjects who had been in some of these experiments. And this is discussed in detail. Right.
The variation in these numbers is a measure of the statistical fluctuation from sample to sample.
So that variance, yeah, I mean, well, but again, you're under different conditions here.
In the second
In the
column.
second column,
And-
the conditions are all the same, but in the second column,
In the rounds 1 to 10.
Oh, these,
Yeah.
the conditions
Yeah.
are the same, but the numbers are different. So
right. This is just variation across groups. Right. Well, and again, this is with low capacity versus high capacity. Okay. Okay. This is one of my, this is results from an experiment that at least I find more interesting than many of the others I've conducted. And this came out of talking about those experiments it was an experimental class. We were talking about those results. And a couple of the students said, yeah, but in many of these cases, everyone's not involved in the decisions. Okay, so what do you do about those how do those that are communicating, how do they solve the problem of outsiders who might take advantage of their cooperation? And a common pool resource, this is this characteristic of rents is that if there's collective action, if there's cooperation that leads to these rents, they can still be captured from others. Okay, so basically we run sort of the same experiment. Hey, we have 8 people. 6 people are sitting there together. They can talk about the problem, and they know that there's 2 other people. They're in a different room. They're outside, and they know that they're making decisions independently. Okay, and they're not getting to listen to what this group is doing, but they get to see the results over time. So we ran 3 different protocols. So in the first protocol, we actually just make these outsiders. And we tell the subjects this. These are actually computerized decision makers. And they're computerized to make this Nash investment. We don't use that term, but we tell them what they're going to do with some variance around that. Okay, so they know that these players are not strategic. All right. So then we go to a case where they know the 2 outsiders are actually 2 more subjects just like them, but they're not talking about the problem. Okay, and they have up to 25 tokens to invest. And then finally, after we do this and we see the results, we go back to this and we restrict these guys. These are real players on the outside. We restrict them to be limited in the sense that these guys were. Okay, so a big difference. So a big difference between here and here is that these guys have a lot of capacity, if they choose to, take advantage of the insiders who are cooperating. So what do we get? All right, this is going back to this variance. This is the first 10 rounds. A lot of variance in groups. Again, there's no coordination. This is once communication starts, and this is face-to-face communication every round. So we're getting something like 80% of rents in Protocol 1 and Protocol 3. Okay? So this is the case where those outsiders are very limited, or they're computerized players, and this is what we get when in Protocol 2, when the outsiders are able to take advantage of cooperation by the insiders. So what you see basically is the rents that are being earned in these rounds overall are much lower. Basically, the face-to-face communication is much less effective in this world in which these outsiders can take advantage of cooperation by the insiders. And in fact, that's what we see in summary. The human outsiders respond strategically to the opportunities created by the insiders, but maybe just as importantly is the insiders start to deviate more frequently from agreements than what we had seen when there weren't these outsiders. So they start using the outsiders as a way to cheat and to try to hide their cheating on agreements that are being made. And then we also see that the insiders anticipate these issues and their communication starts to fall apart. They start to lose this ability to come to agreements. Okay? So again, sort of pointing to the importance of, in a common pool resource situation, if there's sort of not full cooperation, you run this risk of outsiders taking advantage of the cooperation that's going on by insiders. This was sort of a clear example of that. Okay, so moving beyond the experiments, so what if we move toward a world in which we can assign property rights? So we move to a world in terms of individuals or groups of individuals have these property rights to the resource, okay? And we think about their willingness to accept to sell off those property rights. And if we think about this in a world of competition where individuals are price takers, so there's competitions where the buyers and the sellers are treating, here's the price, here's what I would do at this price. So they're not strategically negotiating and things like this at this point. They're price takers. So think about that world for a minute. So we basically end up with a standard model of, in economics, of perfect competition, and the use of the supply and demand model, where it's really meant to be. So we have this idea of minimum willingness to accept. So you have those individuals with appropriation rights. Some are willing to sell at this price. Some are willing to sell at this price. Some are willing to sell at this price. So we think about ranking those minimum willingness to accept from low to high. Take those people who are interested in buying that water, buying those rights. We rank those from highest to lowest, and we come up with this idea of a competitive equilibrium price. In this case, everything works perfect if we can set up this type of market. So we have those who value the water the least, but have the property rights, selling to those who value it the most. Okay? So we get efficient outcomes. So does that work? Well, in a sense, it does, as long as everything works very, very well. So what are the problems? Well, I think what we know, and maybe things have progressed in the case of water in California better than we might have expected. But what we need is an assignment of effective property rights. And I know this, at least in the case of markets and fisheries at times, has been a real problem. Okay? The assignment of effective property rights, so if you're going to sell off your rights, then they have to be well defined. There's transaction costs. So if this market's going to work, where people can still, potentially these outsiders can take advantage of this cooperation, we have a problem. So we need information, we need monitoring, we need enforcing. I guess I won't get into externalities. So externalities are there even in perfectly competitive markets. There's this idea that the process itself of consumption or production can lead to cost to outsiders outside the market. And then in the end, I guess in many cases, you need public acceptance of the allocation process. Somebody's going to be left out, and somebody's going to be feeling like, well, wait a minute, where do I stand in this assignment of property rights, in this mechanism that's leading the allocation of these resources to those who are willing to pay the most and have the ability to pay the most. So, my final slide. So I'm going to come back to Lynn Ostrom for a minute. And so beyond chapter 4, so Lynn's life work in many ways was thinking about the commons in a lot of different settings and thinking about where, in looking at these field studies and even looking in the lab, where do we see the most effective collective action taking place in the commons? Okay, and Lynn starts to look at these cases, and she starts to kind of come up with what are the conditions under which we're finding what she eventually calls design principles. Where do we find that collective action works the most? So this is sort of a subset of those that I at least I find particularly interesting. So in her work, she shows that there's this need for clearly defined boundaries. And those boundaries in this case includes things like appropriation rights. Again, we're back to effective appropriation rights. We need effective monitoring. Otherwise, we have this problem of those who don't have the rights taking. Okay. So Lynn found, at least in the field, and many of these cases are in developing countries, she would almost always find sanctioning mechanisms, and she would almost always find graduated sanctions. So it was a process in some sense, of trying to maintain the collective action through steps of, if there was a violation of the rules, then you would see graduated sanctions. There's a need for appropriate conflict resolution mechanisms. They will arise, so you need something there to take care of those problems as they rise, and rules designed to address appropriation and conflict across larger overlapping resources. And this is actually where Lynn was going when she passed away, is more and more of thinking not just about a resource, but this resource sitting as part of a much larger resource that's nested, and the problems get more complicated. But for success, you're going to have to think about those issues. So finally, if I heard her say it once, I heard her say it 1,000 times. Lynn really emphasized this idea that, and I think she did because she thought that too much of the literature was trying to make this too simple. There are no panaceas. So there are no panaceas in the sense of there are differences between different cases that need to be considered if you're going to have successful collective action. And often, in many cases, there's this need for local information, local conditions. So Lynn was very much had a concern about sort of top-down approaches to solving these problems. And her interest then, as it grew over time, was showing and pointing out this need for thinking about the problem from the grassroots level, what's going on at that level, and that information going up. Okay? I think other than references, if you, Lynn Ostrom, 1990, Govern the Commons. If you like this book, buy it. And if you really like it, buy this book, Ostrom, Gardner, Walker, Rules, Games, and Common Pool Resources. This is also a really interesting paper from Vincent Ostrom and Thibault and Warren, 1961, American Political Science Review, thinking about the organization of government in metropolitan areas and overlapping jurisdictions. It's an insightful paper. The others are, I think, are all almost all experimental papers except for Scott Gordon's paper. So, thank you.